Hello, everybody. How's ScadaFest doing for you so far? Good, I hope. Good. My name is Mike Stark. I'm out of Dayton, Ohio, and I cover Ohio, Kentucky, Tennessee, West Virginia, and Western Pennsylvania. And just a little bit of background. Toyota Georgetown plant has been using VTScada for 23 years. And about a year and a half ago, we were very happy to figure out that Toyota wants to use VTScada for all of North America. So one of the main people behind that is Jesse Daniels, who is now the engineering manager for maintenance and spare parts. But he's going to go into a bunch of different details on how VTScada has helped Toyota and hopefully will help them in the future. So without any further ado, Jesse Daniels.
Thank you. Good morning, everyone. Like he said, I'm the engineering manager for maintenance and spare parts new model. I started that this year, actually. Prior to that, I was with the environmental and facilities department. I've been with Toyota almost 10 years now. I actually started as a co-op in the environmental department at the Kentucky plant and moved over into facilities, and then most recently I was actually the engineering manager over facilities at our West Virginia powertrain plant. So it's always interesting when I get into this discussion, people ask how I got into controls and machines, because my background is actually, my degree is biosystems and agriculture engineering. And I just always had a kind of a knack for this sort of thing. So once my friends and family found out I worked at Toyota, I'd always be getting calls, hey, I have this 95 Camry that has almost 400,000 miles that's making some noise. Got the wrong guy. I'm like, if you need help with your router or like your HVAC, I got you. But anyways, that's a little bit about me. Safety commitment, I will always ensure my team members have the correct tools to do their job safely. So we always start off with safety commitments at Toyota, so I want to make sure that I say that. So I'll get into it. Got a lot of slides to cover. I'm going to go through some of them quickly and spend time on the important ones so it can kind of focus. So the items I'm going to hit today are some background for Toyota operations in North America. Then I'll move into the organization for TM&A, the environmental and facilities objectives and gaps, a little bit of our Toyota production system. That's where I'll spend quite a bit of time. Then I'll show where we've used VTScada within our operations, and then I'll touch on the Toyota Environmental Challenge 2050 a little bit and how environmental and facilities leads towards achieving that goal. So first off, we've been in North America for more than 65 years with a total of a little over 45 billion invested, 64,000 employees. 77.4 million cumulative vehicle sales, and local purchasing of parts, suppliers, and such of 31.1 billion. In the U.S., we have manufacturing sites all over. As you can see, our headquarters is in Plano, but we have Princeton, Indiana, San Antonio, Texas, Blue Springs, Mississippi, Huntsville, Alabama. We also have a joint venture with Mazda in Huntsville, Alabama. Liberty, North Carolina is our new battery plant that's being built currently, Buffalo, West Virginia. Ann Arbor is our R&D center, and then Georgetown as well. And here are the vehicles they actually make in the U.S. You can kind of see there. And we have a couple sites in Canada as well, over at Woodstock and Cambridge, Ontario, where they make our RAV4 and RX, some Lexus vehicles. There you can see. And then also in Mexico, we have our Tacomas that are built there in Baja, California, and then Guanajuato. They make those. Tacomas there. So most recently, a lot of people have given Toyota a little bit of, I'll say bad press, because they don't think Toyota's pushing quite as hard as some of the other automakers, but we've actually started building this plant. I was there a couple weeks ago. I'll actually be going back next week. It'll be up and running in 2025, but that's Liberty, North Carolina, like I said, $5.9 billion investment, 2,100 total, and we'll actually be producing hybrid electric vehicle batteries there and battery electric vehicles. And something I wanted to touch on and share this, because Toyota's come out with this publicly several months ago, but for those that aren't familiar, I'm just going to touch on it briefly. It's called the 1690. So Toyota's goal and mission statement to customers has always been provide the most options to the most customers to best fit their needs for what they want, whether it be a truck or electric or hydrogen or whatever it may be. So they did a study and was showing and released this, the raw materials needed to go into one fully electric battery vehicle could produce 6 plug-in electric hybrids or 90 standard like Prius type hybrids. And just to show that we're going by that logic, here's everything you can actually buy from the Toyota and Lexus brand that has an electric option. So I just want to touch on that a little bit to give some high-level information about Toyota, and now I'll start to kind of get into where we are in the organization as far as manufacturing. So we have our chairman that's actually in Japan and Toyota. Our president and CEO reports to there, and so the sales and manufacturing all report up through that. Toyota Financial Services is a separate entity, but we fall under that manufacturing category, and specifically the production engineering department. So I have a short little video here I'm going to show that kind of goes over what we do in Georgetown.
Production Engineering, the division of Toyota North America. We imagine, design, plan, and build the processes, assembly lines, machines, and factories that bring Toyota products to life. We focus on the safety of our team members and develop facilities and workplaces with an intentional focus on the environment, harmony with nature, and sustainability. Our work encompasses everything from connecting data points to connecting metal parts, planning costs and planning equipment maintenance, and studying new technologies to implementing new ways of doing things. Our diversity is our strength. We know that looking at things from different perspectives allows for continuous improvement and innovation. Our dynamic team of nearly 2,000 engineers are spread across North America, leading production planning for Toyota's manufacturing sites and retooling assembly lines for production. In production engineering, we work to ensure the safety and feasibility of mass-producing new products with competitive cost. We combine digital information from the factory floor with design data to decide what new manufacturing equipment is needed, what can be reused, and what requires modification. We partner with various suppliers to design and build the required equipment for production, and we prepare the site for equipment installation, while adhering to strict safety guidelines. We execute multiple trial cycles of equipment and process to confirm safety, quality, and productivity at our manufacturing facilities, focusing on discovering any problems that may appear during high-volume production. We are also responsible for the lifecycle management of manufacturing software and equipment. We support manufacturing kaizens, tackle major facility refurbishments, and challenge ourselves to innovate using new and existing technology to improve our products, manufacturing processes, and engineering methods. We are working today to create tomorrow's success stories.
So that's very high level, kind of what the production engineering department does, and I wanted to show that because environmental and facilities, the group I came from, and prior to 2021, they all reported, so you had your individual facilities and environmental entities. That Alabama environmental and facilities would report to Alabama, Missouri would report to Missouri, Kentucky to Kentucky, so on and so forth. And as part of coming into the production engineering department, it actually transitioned, and we went to a regional operating model so that every environmental and facilities engineer, manager, senior manager, and such came up to one group manager. And I want to highlight this because this is one of the main things I'm going to be talking about, the problem we faced and the gap, but then also give credit that this is one of the reasons we were able to implement our solution so quickly. As many of you know, I'm sure whenever you have a lot of different hands in the pot that have different opinions and want to make decisions, it can be very difficult to come to a consensus. So having one guy that can basically say, this is what we're going with, makes that process a whole lot easier. So what we struggled with is after the merge, they kind of came up, at Toyota it's called our Hoshin, but it's basically specific objectives we're looking at each year or focus items that we're going to work on. So after the merge, one of our main Hoshin items was to drive adoption of best business processes, technology, and vendors across the combined organization of planning, operations, and projects, considering the uniqueness of each manufacturing and non-manufacturing location. So I talked about we have 14 manufacturing locations, and I said over 30 non-manufacturing. It's actually closer to 80. So as part of this merge, we also took over all of the ports, any sort of parts distribution center, a lot of the training offices and sales offices. So all the facilities maintenance, HVAC, air compressors, whatever they may need, lighting, parking, we would handle all that. So we have this big entity all around that we need to try to manage as effectively as we can within environmental facilities. So the way we wanted to do that, we want to provide exceptional customer service, or customer support rather, through increased efficiency and reliability at the lowest cost, try to automate monitoring, alerts, and reporting when feasible, and the commonization of KPI across sites with flexibility to create custom dashboards when needed. So to kind of visualize it a little better, these are just manufacturing locations minus the R&D and HQ, but we had more than 15 different applications we used across each of those sites to view and or control. So we had multiple license and versions to maintain, proprietary communication protocols. We had a lot of mix of industrial and commercial equipment, so the backnet, like Glenn was mentioning earlier, trying to help. And then also we had lack of standardization and visualization. And not to say there's anything wrong with some of the other products, and in fact, a lot of the makers, we still are going to be using a lot of their hardware. Great hardware, but maybe could only be used with their software. They wanted their front end to be able to communicate with everything else. So we're still going to be using a lot of different OEMs, I'll say, hardware, but to ensure that I'm not throwing rocks or anyone, I've obscured some of the names that we may need or that we may be using, so that it makes it difficult. I don't want Toyota saying they were bashing anyone, because they are great products. So we have Snyder's Electric, Jimson Controls, and Stonewall Automation. So I'm sure you guys can't guess what any of that is that we are going to continue to use. But then our gap was, how do we take all these sites that have, some of them had it 25 plus years, and bring it under one single, what we call andon, which I'll talk about in just a minute, so that we can view, because all the management of our new organization was in one building in Kentucky. So how are they going to know that compressed air is good, chilled water is good, any other aspects we may need without getting a call saying, hey, you shut down production? So I know it's probably a little odd, some people, Toyota's here, but we're the utility providers for those plants. I mean, we're the size of small cities in some of these locations, so it's very imperative that we have good information, good data that we can share. So, Toyota Production System. This is what I'll spend quite a bit of time on, because whenever I was talking about with Trihedral what I kind of wanted to cover, to me, the thing Toyota is best at is processes and following those processes. So I'm going to go over high level some of the Toyota Production System, but then I'll actually show the specific example of what I used when I was an engineer in facilities to go through the selection criteria and process that ultimately led to us implementing VTScada. So one of the two main pillars in the Toyota Production System is something called Jidoka, and the objective of that is to work efficiently, prevent equipment breakdown, and ensure quality 100% of the time. So they want you to own that process, and basically when I hand it on, no matter who that customer may be. So for me, my customer is not the person actually buying the car. My customer is production, because they're the ones using the compressed air and the chilled water and the HVACs. So they try to keep in mind the whole time down the line, who's your ultimate customer going to be? For the ultimate goal of the Toyota Production System being highest quality, lowest cost, and shortest lead time. And one of the aspects of that Jidoka pillar is what's called an andon. So literal translation goes to paper lantern, functions as flashlight, signaling device in the distance, or commercial sign. In manufacturing, it's a control device that we use. So here are a couple examples of like a simple andon or a complex andon. So the simple can change from yellow to green. Any manufacturing plant these days, any sort of lean manufacturing, you're going to see this sort of stuff. They have what they call line mimics. So it actually mimics how the vehicle or the engine moves through the line. And then here's some of the older ones where they're just light up boards that they're seeing. So we were trying to decide, how could we pull all of this in and actually use this, because that's exactly what they're doing in the Toyota Production System out on the floor. So another principle that's kind of the way you get to Jidoka is something called Jikote Kanketsu. And if there are any native Japanese speakers, please don't throw me under the bus for saying it incorrectly, because I'm sure it's not exactly as it is. But this is Kichi Toyota. So just a quick tangent that's very interesting. The Toyota actually started with a lot of these processes building back in the 1920s a loom. The very first Toyota vehicle was actually built in the back of a loom factory. So he built and designed looms, and then ultimately Sakichi Toyota's son is the one who founded Toyota Motor Corporation. So very interesting fella. If you ever have time, do it. But the steps of JKK are very simple to follow, but then the process is a lot more detailed than what it shows here. But the main steps are identify job objectives and outputs, develop an optimal work process, and then establish that developed work process. Sounds a little bit too easy, right? So once we get into it, step one, job objectives. Who are your customers and what are the ideal state for your customers? Final output, you want to identify the product and service, the timing, method of delivery needed to achieve the ideal state for the customer that you mentioned earlier. And then you have to give some job priority and background. Why did we go into this process? What was wrong with it? Was there no standard in place in the first place? Do we have a lack of experience? A lot of industry folks are going through that time where maintenance guys are retiring, we're getting fresh faces in, and they just don't have that same experience and skill set, which is why your process should be set up in such a way that it is independent of the people. We want to make sure it's great to have knowledgeable people, but if you have a good process, anyone can step in, pick up, and learn from that and move on. Or maybe it's just simply you're not meeting KPI, cost, quality, whatever it may be. And it goes for municipalities on wastewater. It doesn't have to just be manufacturing. And that's what I'll show. I actually used this in selection of what system we were going to use or how we were going to combine it all. So for step two, you show your optimal work process development. Typically 4 to 6 steps include who does what and when. So what that actually looks like is you have a chart on the left, who's going to do what and when, and here are the rough work steps as we go through. But then what you actually have to do is break down those rough work steps into detailed work elements. So each rough work step or each work process should be comprised of multiple detailed elements. Each element should have output. So how do I know what I want to achieve from that process? Judgment criteria, how do I know that I've succeeded? What's going to be my KPI when I actually implement this? And then the last part, and this is very, very important where a lot of people get caught up, are necessary conditions. What has to be true first before these other things can fall into place and I can make that happen? The judgment criteria should be specific and quantified, and necessary conditions should consider skills, tools, resources, anything you may need to make that happen. So what that looks like is rough step one. Now you break it down into detailed work steps and go through all those. And the intent is you'd actually work along and go through each of those work steps and show it out. And then lastly, this is the most difficult part, even Toyota struggles with internally. We're a big company, but the process establishment. How will you document the standardized work process? What are you going to do to make sure it's very clearly visible? Toyota is a very visual company. They want to walk up and quickly see, just like I showed with the Andon, hey, something's wrong here. What do I need to do? How will you manage the sustainment of the work process? And then this is a big one. What events will trigger the need for a revision? Oftentimes in the environmental and facilities world, we were loosely shooting ourselves in the foot. Something would happen, we'd lose maybe the dew point on a compressed air dryer or some chilled water. We may have issues with HVAC or the paint shops being able to meet process, and we find out, oh, here was a change point, but we didn't actually update our standard correctly to be able to make that happen. So what that ultimately looks like, I'm going to show kind of the example that I did. This was actually 11 by 17 portrait, but I went through exactly what I was talking about. So my quality, schedule, cost, my final outputs for environmental facilities, proactive awareness and Kaizen of operations across North America at all levels. So whenever we merged as part of our energy goals and just overall cost goals, we meter everything. I was doing a Power BI where I was having to pull from about 6 or 7 different databases from all the plants, trying to then visualize it, normalize it, and make something meaningful of it so we could see. I'll touch on it in a bit, but one of the big things we were trending is called non-production energy. So TMC in Japan came out with a challenge for us, basically as low-hanging fruit, free money. On the weekend, when we're not running, we're not building plant or vehicles or engines, why do we have equipment on? That's just sitting there, no need for it. And then also in between shifts, if it allows, which we run overtime and such, but they were basically challenging us, what can we implement that we can start getting paint booths turned off and fans and raise HVAC set points and things to stop wasting energy when no one's there and we're not building any product. We wanted it real time. And then we wanted to develop a system to enable that. So kind of some of the background I was talking about, 14 NAMs and 80 plus non-manufacturing come together in the regionalization of environmental and facilities. We had multiple platforms. There was noisy data because not everyone was taking the same sampling rates. Not everyone was pitting it in their visualizations together would be easy to see that non-production energy. So all those combined ended up being delayed reporting for us. So this is a little overwhelming, I know, but I'm going to spend a few minutes walking through it because it was easy for me. It wasn't a who over here because I knew it was all our department that was going to be handling this. But essentially, I went through what's the ideal workflow, and this is what you can do no matter what your process is. So for us, it's building operations. I need to make sure the building's there. They always joke and say facilities is very similar to IT, and my group manager, my old group manager, used to say, if we're doing everything correctly, you guys don't even know we exist. You come in, lights are on, feels comfortable, air conditioning's good, there's no clogged toilets, everything's working as it should be. It's not leaking through the roof on a sub panel of any sort or any sort of electrical equipment, but it happens all the time. So our start is we're just operating the building. We have to have metering in place to get to what we need. Data storage, and then that optimization, the real-time visual management, the reporting, reflection analysis, and Kaizen. So then on the outputs I go through, I show building operation, that's an easy one. Metering, 100% of facilities operation data is captured. So I'm going to capture everything. I need it historized for 5 years. The optimization, I need to go through all that, sort it out, normalize it, make sure that it's something that someone can actually read. Real-time current status of all core systems at once. I want the historical trends, and then on the reflection analysis, we should be getting better and better. It mentioned Kaizen in the video. We want to see and have a system that can show us where we have inefficiencies and how can we get better. And then for the ultimate KPI reduction, cost mainly, but also quality. And then I go through and on the judgment criteria, utilities need to be provided. It needs to meet the North American metering standard. 100% of data needs to be captured and available. Real-time visual management, understand the criteria for the core system. How can I view it? How am I going to know if it's good or no good? So I went through and basically showed what needs to be true for all this to happen so that we can ultimately get to this new system that we were talking about and discussing. And then ultimately, I made a nice little visual form just to show high level as management. Operations, we're picking up meters or equipment's going into a database. We're trying to filter some of that out, get the good clean data on some known basis that's standardized across all North America. And then we want to visualize that in the end-on, have the reporting. We'll use the reporting to reflect and say, oh, well, maybe the Kentucky plant, why were you using a ton of energy this weekend when no cars are being built? So at that level, we can see, because it's more wear on the equipment, it's more cost on the facilities department, whereas we need to be as efficient as we possibly can without shutting down production. And then ultimately Kaizen, and then that loop just continues on. So what's nice about this process, here's kind of what it looks like on that 11 by 17, or you could put it in a PowerPoint like I did, but it gives you exactly what you need for the product selection. It builds your criteria for you. So what are the functional requirements? What are the things I can't live without? It absolutely must do. What are the non-functional requirements? It'd be nice if I could build it this way or if I didn't need any coding. So for us, one of the big things in facilities, we love partnering with vendors. Toyota has great relationships with vendors, but we don't want to have to call them every time we need a small screen change or to move something from here to there. So a big key for us was we want to be able to own and maintain it in-house to some capacity. Total cost of ownership, a lot of times that gets forgotten about when you're going through it because maybe they have a cheaper purchase price, but then it's a sales as a service or something that's continuing the ongoing costs more and more and more. The timing, how quick can we actually implement it? Usability, how much training is going to be required, going back to that documentation, and then ultimately the sustainability. I've also often said Toyota is wonderful at a lot of things, and one of those things is breaking software. We're just so big. That's one of the reasons that VTS has really worked out for us. I'll show here in a few, is because they've worked through us. We had a few hiccups, but we managed their way through them. Great support from the team, and we're just trying to get better and better to make sure we can do what we need to do. So ultimately, I talked about all that. We have our environmental equipment, wastewater systems. We wanted to be able to pull in some of our safety metrics, so GIR, TR, what they call it, OSHA, any sort of recordables. Also pulling from IBM and Maximo to look at our cost data, our facilities equipment, and then maybe some of our legacy systems that we're still using the front end, remain hardware. We want to pull those in, so it's one nice big visual. Ultimately, we'll go to VTScada that we've been, it's now implemented across North America. We have it in every site, and it only took about a year and a half, truly, to roll it out. And then ultimately, it'll also go into something called the Toyota Big Data Platform, which is our data lake, so that anyone across the globe and the Toyota network can actually access and see if I want to see how my powertrain plant is doing against one in Japan or maybe Thailand or South America, wherever, they can come on here and get that data and have access to it. So now I'll kind of show you some of the stuff we're doing within Toyota with VTScada. So for us, again, I said you had to go back and decide what's going to matter to you. So for our particular department facilities, we were looking at chillers, compressors, cooling tower, HVAC, water supply. So we have RO water, domestic water, non-potable water, electric. We're looking at the tank farms, our wastewater system, and then the sanitary systems as well, lift stations and such. We're pulling trip alarms, run status, power efficiency, and then on a system level, we know what that equipment was designed to do, what the output should be. So we have, again, an entire process where we go through and look. It's called SSR, Shop Self-Reliance, where we see, is that site maintaining what they should be? Is the equipment taken care of? And how good are we doing? So we'll look at quality, like pressure and dew point, utility capacity versus the actual demand, how many units are running available, and then the efficiency versus equipment design, like I mentioned. And so what this ended up looking like, and I kind of moved on to West Virginia, and Chad and Scott, who's in here, helped from the planning department. But for a high-level facilities, this is kind of what we were looking at. So the legend down here, you can see, whoops, sorry about that. We are in hours in red, days in orange, and days in yellow. So as a manager, you want to be able to walk up and see, mostly green, I'm good. If I start to see orange there for a little while, you know, HVAC, maybe I've had some sort of DP sensor, maybe it's production critical. Not all of our HVACs are production critical, but some are. But I need to be able to quickly walk up and discern where I need to pay attention to. And specifically, if it's in the red, if there's a risk of production, we want to countermeasure that as quickly as possible. And they're working on, North Carolina does have it, VTScada now, and then I believe Mexico's installed and Canada, so moving right along. And then what is helpful is as a manager, you can then also drill down a little more. You want to have dashboards standardized for all NAMCs. That's something I mentioned because all the different systems we had previously really didn't look the same, navigate the same. So as someone in the corporate side of Toyota, it was difficult sometimes to be able to navigate and go through those screens. Out of spec alarm indication. You know, he showed some of these HMI screens earlier that Toyota does use to be able to get a quick glance. Specific equipment is identified if there are any sort of alarms. We know exactly which air compressors having issues. Reliability, function of capacity, so we can see I got 1 unit running, 2 units available. Equipment details, you can actually, you know, a lot of you know VTS, I know, but you can connect to the equipment, actually see everything you need. And then obviously the historical trends are important. And the big thing for us is reporting, which I know Glenn touched on, and being able to customize screens, because in my old role, I've spent months trying to think of every single possibility, and it never fails. Day one, I go show it to a production manager out in the assembly shop, and they're like, yeah, that's okay, but what about adding this? I'm like, okay. So having the option for them to maintain it, them to be able to make changes themselves was crucial for us. And so for sites with multiple utility buildings, there's a landing page that you can go, and then ultimately our goal is to build these same systems. And similar to how you receive your electric bill at your house, we'll actually be able to show our plant presidents, you know, here's what the assembly shop was using in electric, here's what they should have been using, here's what our paint shop's been using in natural gas, here's what they should have been using based on the number of vehicles they actually produced. So very important for that. So as a senior manager or manager, like I said, you're going to come up and you want to kind of get a quick glance. So I'm looking for warnings, high critical alarms. How many days or hours are they in alarm? For critical production, I need immediate action. I need them to go out there and fix it. For high alarm, is there a plan in place? Do I have something to resolve that? And then as you go down to the engineer level, we start up at the higher, and all these will click through. You know, you're familiar with VTS as you go through. And ultimately, I can get down to the individual equipment and the important KPIs that I'm actually worried about. So this is an air compressor, and we actually have water leaks, vibration for each of the stages. It's trending that entire time, and we're working on doing mobile check sheets in there as well, because Toyota has very good processes, and a lot of those are still paper. So we're trying to move over in facilities and use as much as we can. So as an example here, we have a team member, part of their daily work, they go out and write down what's the vibration and we trend it out. That way, if we have any sort of issues, we can come back and say, oh, or, my vibration started to come up here, so I probably need to look at doing the PM for that particular piece of equipment. And then ultimately what I have here on the right is, depending on the alarm, we have multiple root causes, what are the countermeasures and comments. So again, going back to that standardization, not that we can think of everything, but in the 30 plus years that the manufacturing sites have been around with a lot of those facilities people, they've probably seen something similar. And so it requires, anytime something new comes along, you go back and you update that documentation. You go back and say, here's the process that I need to improve. That way someone new comes in, oh, well, I'm having vibration problems. Here's a list of what it could be. What do I think is most likely? And actually begin that troubleshooting, go through and check all of those. And then it moves on down even to the group leader and team leader level. So as I'm looking at that equipment, they're going to utilize it for shift turnover in between first, second, third weekend, and then use the condition-based maintenance approach for investigating and implementing countermeasures. So depending on the site of your organization, or the size of it rather, you may not have the time. I'm sure maintenance people are struggling to keep up. So we want something that is going to be connected with the equipment and let the equipment talk to us, rather than just having every 3 months I'm going to go change these HVAC filters. Let's make sure we're implementing, and then sending out based on when it actually needs it, because depending on where that HVAC's located, maybe you have some oily mist in the air, maybe it's a body weld shop that's really dirty. Some of those are going to need cleaned and changed more frequently than something that's in an assembly or just a conveyance area. So this is kind of how we use it within Toyota to roll down downstream. So some big things, and I'll cover some site-specific screens here that we've covered through a few of our NAMCs. One of them's at TMMK. The ability with VTScada to view unique systems in unique buildings at the same time. So I told you about North Carolina coming up. Once it's complete, it will actually be the largest Toyota facility in the world. Currently, that goes to TMMK. So they have somewhere over 9 million square feet under roof. Technically 3 plants, and one of the things that makes them the biggest, they have a vehicle plant and a powertrain plant on the same site. But from the facilities aspects, we monitor and control all those utilities from 3 different buildings that are spread across the site. So I always get looks of shock whenever I show some of these screens, because it's not a management screen. This is meant for an operator, someone who's actually there. And Neil, sitting in the back, can give you all the details you may want about this. But here's kind of an overall site we have by building. It looks a lot smaller on here. Some of our wastewater processes, but then like chilled water, for instance, I need one screen that's going to show me where am I having chilled water problems and what could that problem be. And so it gets a little bit busy, but you're able to tell, I have my 501 building chilled water, I have my 801 building chilled water, and I have my 508 building chilled water. And I'll say the first thing Toyota actually brought VTScada in for so long ago was the compressed air system, and then it slowly moved on to chilled water and wastewater. And what's so nice about this, some of the plants kind of laugh, especially newer ones, because they're used to these pretty 3D graphics that system integrators provide, which, like I said, is great for management. Some of these screens haven't been touched in years. They work. You don't have to mess with them. If the operator knows what he's doing, leave it be. Don't touch it if it isn't broken. You can try to improve on it, but give them something here that they can see. So I know exactly what my efficiency of my chillers are, the kilowatt per ton, which chillers are running, which ones can't run, what's my supply water temperature, what's my return water temperature, and so on and so forth. So the ability to have such a large site and view everything in such a compact screen is huge. So one of the other things we've done recently is the ability to what they call Yoke 10 within Toyota. That means I take a process here and I also implement that countermeasure somewhere else where I could have the same problem. Maybe it's a machine or an HVAC had a problem. I fixed it, so then I'm going to go out and look at all the other HVACs that are that make and model and implement that same countermeasure. So something our Indiana plant had happen, unfortunately, is last August, if I remember correctly. About 10 p.m., they got a low alarm on the LLC tank, which, vehicle production, you got to be able to put some coolant in there. And they slowly watched it go down farther and farther and farther until, I think it was about 5 or 6 a.m. They finally were able to get a tanker to come, but we ended up shutting production down, the assembly plant. And so facilities, that's the bad part and the good part. If everything's good, we're doing our job right, you don't know about us at all. If things don't go well, we're not just shutting down one line, we're shutting down the plant. Everyone's leaving, everyone's going home. So TMMK had actually set up years ago a tank farm screen, and then they actually built even upon that to allow our contractor on site that manages our chemical deliveries a screen that actually showed them each of the tank names, what the product is, our YN number, or how we order, and basically what can it hold, what's the capacity, and what's the level. Can I go ahead and order a tanker? Will it hold it? And so some of the team members in Indiana actually reached out, worked with some team members from Kentucky, and within 2 days, they had it copied, pasted, pointed at their PLCs, and then they were up and rolling. And that was a newer team member who really wasn't that familiar with VTS, because TMMI has only had VTScada for a little over a year now. And Deanna and Casey and several of them there have been doing a fantastic job about learning. But that goes back to my other point. It has to be intuitive, that they can go in, and it doesn't take much learning. I don't want to need someone that has Java and Python coding skills to be able to do this little simple screen. Again, it's not fancy, but it works, and that's what's important for our process. So another example, and this one's actually from West Virginia, shortly after I went over there, the ability to create screens with alarms in a short amount of time. So the compressed air system we had at West Virginia in our facilities group house where we sat, we could monitor it remotely up on a little TV. There were alarms there, but the TV really wasn't very loud. It was difficult to know if we were having any sort of pressure issues. And unfortunately, one morning we came in, it was shortly after the start of production, all the machines got turned on at once, which almost never happens, and we dropped. And the way I found out about it is getting calls on the radio and the phone, why don't I have compressed air? And as the guy who owns compressed air, that's not where you want to be. You want to make sure if you start to see a downward trend or you hit your area that you know. So we had another TV mounted shortly up from my group leader's desk. It was 75-inch, probably 10 foot away from it. Within about 4 hours, so please ignore my bad data or questionable data, because I connected to the PLC, I brought it in, and I cranked the volume up on that baby. So I knew I'm going to be the first one to know if I'm having air problems. I'm not going to be getting calls on the radio or the phone. So like I said, 4 hours I was able to create this, and it's still up there to this day. And they jump up and will go like crazy anytime that alarm starts to go off. So it was a good countermeasure that we were going to make sure we knew before the plant knew. Something else that actually Mark has helped me build, I try to create screens. So I know there's different sessions that talked about strategies of rolling VTScada out. One thing I always promised my team members, I did not want to make any of their jobs more difficult. So what was nice is we had all these other systems. I was able to go in VTScada and mimic and mirror the system exactly as they saw it previously, so that there's no learning curve for them. Is it the best way? Maybe not, but at least I can get them using VTScada. We can work through that and then improve over time. So I'd like to give a nice big landing page for West Virginia. It shows some of the critical links. Basically, I gave my team members a one-stop shop. So if they need to hit Maximo, or if they need to know where our cost data is or anything like that, I'm using it as a landing page. And then also the various buildings you can actually click on. You know, we track our solar. This was an old Wonderware system, which we actually still have in place. It was running, but I was able to mimic this. This is VTScada. I made it look exactly in VTScada as it was, so that team members knew what they were doing. Another example, Phil has helped out tremendously with this, one of our engineers down at Mississippi. So the ability to visualize efficiency. So I talked about non-production energy a little bit earlier. So what Phil's actually done at Mississippi, and he's one of the first out in the assembly shops, is he shows total Mississippi, my assembly plant, my top coat area and paint, my ED paint, my body weld, my stamping. Here's where they typically should be during production. Between shift, I expect them to be about here, and then on the weekends, I want to see them about here. And then what's nice is I can drill it down to that even farther, and I can look at the substation, so I can see their bus ducts, actually which is pulling, and you have that ability to give that delineation and move farther and farther down the line so that we can optimize and make the processes as efficiently as we can, or at least be able to report on it. That was the big gap before. If someone wasn't using energy wisely, we didn't know until I refreshed my Power BI, would try to get it all together and send it out. So this way it's real time. They actually bought TVs to stick out in assembly with the andons that show this so that managers can see, oh, we should not be using that much, or maybe this actually indicates the other. We should be here, we're not. What am I not making? What equipment is broken? Why am I not going to meet my KPIs of availability and throughput? So, and then lastly, I wanted to share, Dan is here, he's actually in our paint department. What's nice is there were a lot of competing ideas at Toyota over the last couple of years with some of the Industry 4.0 and MQTT 3.1 versus 5, and what do we need to go through, all those functional requirements I listed earlier. While they can be technical, there's some different decision making within Toyota. So you have IT, who obviously wants to make a system or own a system that's easiest for them to maintain. And then you have the operators that want a system that's easiest for them to use and customize. And then accounting and finance wants the cheapest one, usually. So you have all these different ideas competing. And what we were able to show, especially with non-production energy, because that will go into the Environmental Challenge 2050 that I'll talk about in just a minute, is we have to be able to visualize these goals and capture the data and make sure it's accurate in order to show that we're making progress towards those goals that we've promised our customers and North America and the globe that we're going to do, that TMC has shown. So actually through that, I was working with some of the production shops trying to figure out if any of them would be able to utilize VTScada, because they've historically not had VTScada, and luckily Paint Shop helped me out, and it just so happens Paint's one of our biggest energy users, so it's great for them to be able to hop on, because then they have the ability now to look across VTScada applications, pull in tags that they need that we've already created for them. Whereas if they didn't, they'd either have to come to our system, which they could overload it, or build some sort of other dashboard or visual so they could actually see it. So he started, same thing. He's looking at, you know, for my PTED, the UBC sealer, top coat, all these different areas of line one paint, building that line and on. How are they doing on the electric, gas, water, chilled water, compressed air? What's the status? And then for each of those, am I doing anything, you know, meaningful to actually make a change towards that? So with that, I will talk just briefly about the Toyota Environmental Challenge 2050. I fit up a QR code here if you're interested, but several years back, Toyota came out and said, you know, carbon neutrality, we really want to push towards that, and we're going to do everything we can. And the reason I bring this up is because for us in the facilities department, this promise is honestly what's helped get some of the funding approved for us. We're like, you know, just like I showed, you have to look at the entire process. Am I going to be able to make the target? What are the KPIs? And we have to work backwards from there. And so we got to start tracking and measuring and making things better, or else we're not going to meet these targets. Specifically, we can impact the manufacturing target there. But I'd put this QR code up. If anyone wants to scan it, will actually take you to the Toyota Environmental Challenge 2050, or you can Google it. It'll take you there. And what I really, really appreciate about Toyota is their honesty. So it shows all these targets and goes through them, and then they'll actually rate ourselves right here. Do we think we're going to make it, or aren't we? And all this is public information. You can go. We don't expect to be able to make it because of this, this, and this, but they go through. But it just shows Toyota's promise to following the process and trying to have respect for people and respect for your customer, and then ultimately meet those challenges. So kind of in summary, the objectives and outputs must be clearly defined and understood that quality ownership process, so that the quality ownership process can be developed, implemented, and maintained. Like I said, we still struggle with this. It's tough. We have very, very good processes, but the maintenance of those is something that's never done. You're going to keep continuing, because if you don't have that full scope, how can you really set the KPI to determine if you're good or no good? And this has to do with any process, not just manufacturing. The second point I want to mention, actually, a team leader from West Virginia in the maintenance department told me this a while ago, and I've always remembered it, and he said their processes and maintenance for the South Plant at West Virginia are best ever. So you'd ask him, well, how's that? He said, best ever. And so what he would start saying is, it may be the best ever, but not forever. And that's what he told his team members. We may be the best plant in North America right now, do it more efficiently and cheaper than anyone else, but we're not giving up. We're not going to quit. What else? Where is their waste? Because the whole idea, and it was tough for me to even narrow it down to this. Some of these classes are days just on this topic within Toyota. So, but as part of the TBP, or the Toyota Business Practices process, they work, you look at your gap, I look at the biggest portion of that gap, can I close that? So once I implement a calendar measure, I may only solve 5% of the overall problem. Guess what? It's 5% less than I had. And I'm going to keep going, and then over time, you work your way down to you're the best of the best. And then last but not least, you should have at least one Toyota. I know it probably sounded like a sales pitch, but I'll throw that in there at the end. And then my contact information is right here. If you scan the QR code, it'll take you to a digital card you can download. If you have any questions, please reach out. I'm happy to help. Like I said, I'm not in that role any longer, but I still do a lot with VTScada and trying to help the overall, image and project of Toyota. Thank you.
All right, Jesse, thanks so much. Very, very interesting. Does anybody have any questions for Jesse? We've got a few minutes for that. Anybody? Questions? All right.
What was kind of your time frame to get most of that VTScada stuff set up for everything that you were talking about?
So we actually started a trial. So again, following the business practices, I looked at the plant that had the worst BMS, that had basically nothing, and James, I think I saw him in here somewhere, Missouri is where we went, because some of their HVACs, you couldn't even see if they were running. And they happened to be one of the smaller plants. So what I had to do then as an engineer at the time is, hey, give me this much money, let me go prove I'll take the worst plant and at least bring them up to par. But once we actually got funding and made the decision to go along, we developed a very aggressive schedule to have it rolled out to all of our North American plants within about 18 months. So, and we're still working on that, because this, like I said, Toyota's large, and something we had to spend a lot of time on going through this process is the architecture. What does that look like? And we worked with Trihedral a lot, and they were fantastic partners of how can we set this up in a way that it's not gonna, technical debt, as you called it. I don't wanna go back and rework a bunch of different, because one of TMMK that has had it the longest, I think they're at about 50,000 tags, 50,000 tags, somewhere that they're running, and we're just gonna get bigger and bigger with some of these other plants like North Carolina. But overall, we were looking at about 18 months to actually get it implemented, and then our intent was, just like I said I did with West Virginia, not that we wanted to get rid of all the other systems immediately. We actually set that goal over 10 years. Because we knew that this was a big project that was going to take time. So our intent was to get VTScada into the hands of our manufacturing and operations groups, let them get accustomed to it, and then whenever it comes time for those expensive upgrades, or maybe IT has some networking stuff you need with, well, we're just not going to do that, and we're going to stay with VTScada. So then over time, we would transition each plant to bring in controls, and HVAC was a big part of it. They've helped with some of the BACnet discovery. We still have a little bit of work to do on that, but the idea is do it at a pace that you can succeed. You need to set tough goals, but make sure they're achievable, everyone's on board, and get that consensus from all your users.
Awesome. Anybody else? All right, well, thanks so much. Thanks a lot, Jesse.
Thank you.